Hello and welcome. In this video, I'm going to show you how to get Jasp to give you the numbers you need to complete any factorial ANOVA. We're going to work on the example from activity 9.1 right now. So the first thing you want to do is get the data into Jasp, and I'm assuming you've already done that. The next thing you need to do is label the levels of each of the two independent variables. You have two independent variables. You have drug A and B, and you have gender, male and female. And right now they're just entered in as 1 and 2. That's going to make the output pretty confusing to understand. So it's going to be worth your time to click on the drug label here. And level 1 is drug A. Level 2 is drug B. Hit enter so that it records it. Now you can see down here it's changed it to drug A and drug B. You want to X out of that. And now we want to do the same thing for gender. This was entered such that 1 was male. Enter. 2 was female. Enter. Make sure that that did it. Male and female. And then X out of it. Now we're able to go ahead and analyze the data. So you want to click on ANOVA. Click on ANOVA again. Your dependent variable is always the score, the thing that's measured on the interval ratio score, or interval ratio scale of measurement. So in this case, it's memory score. And then we have, in the design, two different genders, male and female. Those are one of the independent variables, and the other independent variable is what drug different people were given, drug A and drug B. So those are your two independent variables. There's your dependent variable, and you can see what you're getting over here. Hello and welcome. In this video, I'm going to show you how to get Jasp to give you all the numbers you need to complete any factorial ANOVA. This will be good for activities 9.1, activity 9.2, all of the ones where you're doing a factorial ANOVA. This will show you how to do it. The first thing you need to do is have the data in Jasp, of course. I'm assuming you've already got that done. You've got it up and loaded and you're looking at it. The next thing you need to do is recode these levels of the independent variables. So you have drug A, B. Well, right now, drug A is labeled as 1 and drug B is labeled as 2. And that's going to be confusing because also gender, male is labeled as 1 and female is labeled as 2. And that's going to be confusing to read the output. So let's go ahead and give more descriptive labels here. So we're going to click on drug. And drug 1 is actually, we're going to change to drug A. And then the 2, we're going to change to drug B. Press enter after each time, and then you can see that it's changed them to drug A and drug B. Then you can X out of that. Now we got to do the same thing for gender. Male is level 1. Make sure you press enter. Female. Press enter is level 2. So you can see that that happened. We can X out of that. Now that you've got your independent variables appropriately labeled, the levels of the independent variables, I should say, are appropriately labeled. Now you want to go ahead and run the ANOVA. So you can click on ANOVA and then ANOVA again. And your dependent variable is always the thing that's measured. It's the dependent variable that you're measuring performance on. In this case, it is memory score. So that goes over to the dependent variable. And your other box is filled with the independent variables or your factors. So we'll put gender over and drug over. Doesn't really matter which one goes first. And you can see that you get the overall ANOVAs over here. You're going to want descriptive statistics and you're going to want effect size. You're going to want to uncheck eta squared and check on omega squared. And that'll give you your statistics over here. So Remember, you have 3 overall f-tests. The first one is the main effect of gender. So here's your f value, and then your p value, and your omega squared. Here is the main effect for drug. And then here is the main effect, or excuse me, here's the interaction between your 2 independent variables, gender and drug type. And here's your f, and there's your p, and there's your omega squared. These are the descriptive statistics down here. These are the means and standard deviations from basically what we'd call the cell means. So the females who got drug A, this is their memory score. Females who got drug B, this is their memory score. Males who got drug A, memory score. Males who got drug B, memory score. And then there's respective standard deviations. We can see that each cell had 35 people in it. If you need help interpreting these, again, I would encourage you to look at the longer chapter video that I provided. But in a nutshell, you can look at this and you can see that the p-value for the main effect is gender is not very compelling. It's a very large p-value. That tells you that overall, males and females did not have different, there's very little evidence that males and females had different memory scores. The p-value for drug B, or the main effect of drug, is also not compelling, suggesting that both drugs had similar effects, or there's no evidence that one's different than the other. The story is different when you get down to the interaction, however. You have a very large f value. Again, you expect it to be close to 1 if the null is true, and you expect the p-value to be large if the data are consistent with the null hypothesis. This p-value is very small, suggesting that the data are not consistent with the null hypothesis for the interaction f. That tells you, again, that there's something different going on. There's different stories going on for men and women and drug A and drug B. Those drugs seem to affect the genders differently, perhaps. We'll have to go down and look at other data to interpret this interaction. But this is where you would look to see if there's something else you need to think about. And there clearly is. Now, the next thing you want to do is get some of those other statistics. Just going down the line, what you're going to do is click on post hocs and move the 2 factors over and the interaction factor over. You want to click on effect size, and you want to click on confidence interval. And that will give you a whole lot of information that we'll talk about in a bit. The other thing I'd like you to get is the descriptive plots. Doesn't really matter which one you put over first, but that'll give you this picture. I always think it's a good idea to get error bars. And now the last thing you'll need to get is the simple effects. This is what is going to be important when we're interpreting that interaction effect. Now, in the activity, it's going to ask you for the simple effect of males across drug A and drug B. And then it's going to ask you for the simple effect of females across drug A and drug B. So because you want to know the simple effect of males across the other factor A and B, or females across the other factor A and B, you're going to want gender to be in the moderator, the second box, and drug in the first. If you flip these around, if you put drug down here, you'll still get the analysis. There's nothing wrong with doing it that way, but your numbers won't match up with the numbers in the activity because you're getting a different set of simple effects. And this analysis, this activity is asking for, again, the simple effects of males and the simple effect of females. So if you wanted the simple effects of drug A and then drug B, you'd have the drug A down here and drug B, that factor down here. But that's not what you want. So if you get everything's right up above, but you find that simple effect numbers you're getting aren't matching up, it's probably because you have these in the wrong boxes. Okay, so again, I have a longer video that sort of that talks about how to interpret the overall effect, but I'm going to walk you through some of where to find the numbers here in Jasp. So I've already talked about the ANOVA summary table up here and each of the different F values and P values and omega squared values. I've talked about the descriptive statistics, which is the cell means and standard deviations. You've seen the graph. All right. You're also going to be asked for the simple effects and then the confidence intervals and p-values and all that. So the simple effect, you need to go down way down here, and that's going to tell you this is the simple effect for males across drug A and drug B. It's going to tell you, is there a difference on males between drug A and drug B? And you're going to see here that the p-value is compelling, so yes, it looks like males perform differently on drug A than drug B. That's because this p-value is so small. Now you'll go down and look at the simple effect for females and see if it's compelling, and you can see that it is. So this means that females perform differently on drug A than drug B. Okay? So this is where you'd find the p-values for those two simple effects. Now, if you mixed up the modifier, you would have drug A and B here, and that then these numbers would be different and they wouldn't match up. Now, what are the actual mean differences? So if you wanted to find the actual mean difference for males on drug A and drug B, so here's male drug A, here's male drug B, so here is the mean difference between those on male and on drug A and drug B. So that is the simple effect for males. That's the mean difference. This p-value down here is telling you that that mean difference is very unlikely to occur due to sampling error because this is so small. Okay? And then you have the confidence intervals for that mean difference, right? And then this is the p-value. Ignore this p-value up here. This is the p-value that you're interested in that one. Okay. Then for the simple effect for female, drug A, drug B. So here's female drug A, and here's female drug B. So that mean difference is a negative 2.8. And then this p-value tells you that that mean difference is very unlikely to have occurred due to sampling error. Now, I think it's helpful to look at the actual plot here. Higher score is better performance because we're talking about memory here. So for males seem to do better on drug A than drug B. And again, because the p-value for this simple effect, which again was right here, that p-value tells you that this mean and this mean, that difference is very unlikely to occur due to sampling error. So if you're a male, you'd rather be on drug A than drug B because drug A worked better for you. However, the story is different for females. If you're a female, you'd rather be on drug B than drug A. And again, this p-value down here tells you that that difference is very unlikely to occur due to sampling error. So this is your interaction. And again, you'd want to, eventually you're going to have to write up things like this, and how you would do that is explained in that larger chapter video that I produced. But if you want to skip to the end of that, probably the last 10 minutes or so will describe how you write this data up in a good way, in a good APA format. I believe that's everything you're going to need to analyze the data and complete the homework. I'm just going to quick look through here and see if there's anything else. Oh, so these are if you want information on the main effects, if you want the confidence intervals for the main effects, here it is under the post hocs. Male, female, so gender main effect. Here's the mean difference between all males and all females, regardless of what drug they're on. Here's the lower bound and upper bound for that mean difference. And then again, if you want the p-value for that, you have to go up here for gender. And again, that p-value suggests that that mean difference is not compelling. Now, if you want the main effective drug, here's the mean difference. Here's the lower bound, upper bound. Again, you would go up here to use the p-value, again, suggesting that that mean difference of drug is not compelling. Let's see, is there anything else? I think I've told you everything you need to know. Here's the 95% confidence intervals for the simple effects. Now, you notice you get a lot more analysis here than you actually need. You really only need the ones for the simple effect. Again, female drug A to female drug B. So you really just need these numbers here. And then male drug A, male drug B, you really just need these numbers here to complete the activity. It gives you a lot more than you need, which is why you got to know what you need. Okay, so I'm going to stop there. Hopefully that'll go well for you. Obviously, if you have questions, you're welcome to shoot me an email.